In section 4.8, we're dealing with congruence transformations, and we're going to be looking at those in the coordinate plane as well. So what is a transformation? A transformation is an operation that moves or changes a geometric figure to produce a new figure. It's transforming it, right? It's changing into something else, just like the Transformers on the movie. It's changing into something else. So triangle ABC is changing or becoming triangle PQR, and we give terms to the original image. It's called your pre-image, so your original is always listed first. And then that new figure, after it undergoes this transformation, is called your image. It's the new figure that you get after the original figure undergoes a change or a transformation to produce a new one. Keep in mind this word image is the new figure that you get after the change. There are three main types of transformations. We have translations, which a translation is a slide or a shift. It moves every point in an original figure, or every vertex, the same distance and direction. So it's kind of like a slide or just a movement. For instance, if I had this triangle, this shape here, and I was doing a translation, it would just be like copying and pasting it and just moving it somewhere else. And everything moved some distance. Okay, it translated, it slid that much. I went from vertices that were common, and that would be my translation. A reflection, it has to have a line of reflection, and it's basically creating that mirror image. It's reflecting over a line. So if I have a line right here, and I want to reflect something over it, if you think about it, on here I would have to do like a flip after I copy and paste, right? So I'm going to copy and paste this, but if I'm reflecting, I would be flipping this over, and then I have to rotate it till it looks correct over that line, till it looks like a mirror image, and it would end up right about here. Okay, so reflection is over a line to create a mirror image. And finally, the last type of transformation we're going to talk about today is a rotation. And you're turning a figure about a fixed point, and that point is called the center of rotation. So if I take this triangle and I want to create a rotation, all I have to do is copy and paste it and grab that bar and turn it, right? So that would be a rotation, except it would be rotating over a point, which that point would probably be about here. Alright, but let's do some very accurate transformations of translations, reflections, and rotations in Geometry Sketchpad. So I have a triangle already here. Now a translation, all I have to do is highlight this, and I go to transform, right, because that's what we're doing is transformations, and I'm going to translate it. I'm doing a translation, and I'm going to do rectangular here. Now you see that I can do a horizontal distance and a vertical distance. Horizontal means left or right. Right now, this triangle, you can kind of see the shadow of the new one, is moving to the right 1 centimeter. What if I wanted to move to the right 5 centimeters? Now you notice it does go further to the right. The vertical distance is going to do up or down. Maybe I want to go up 7. Well, there you go. Maybe I only want to go up 3. Maybe I want to go down, so then I put in a -2, and this thing goes down and still to the right 5. These are all translations because it's just shifting or sliding, translating where this triangle originally was. Then we had reflections, and we need a line of reflection. So I'm going to put a line in here, and what I have to do is in the transform I have to mark this as my mirror. Remember that a reflection uses a mirror image. So this line is my mirror. I'm going to highlight my shape, and I'm going to transform by doing a reflection. I'm going to reflect it. There it is. It ends up on the other side of that line. I can change how that line looks, but notice the shape is still reflected over that line, my triangle. I can even change how the triangle looks, but notice it's still reflected over that line. Alright. And the last thing that I could do, remember, was a rotation. So I'm going to highlight this point, and I'm going to mark that as my center. A rotation always has to have a center of rotation. And I'm going to highlight my triangle, and I'm going to transform by rotating it. Right now I have it going at an angle. It's going at 90 degrees, and you notice it's going sort of counterclockwise, rotating at 90 degrees. You can change the angle to 180 degrees. It'll end up on the other side of that point, but in a rotation sense. I can do 90 times 3 would be 270, so 270 degrees. this way would be 90 degrees clockwise. Yeah, I can look at a rotation. It's always going around that point, by the way, so, whoops. It's always going around that point. Now that I screwed it up, I apologize. So I can grab this point and kind of change where that is and how the rotation would look. This is still going 180 degrees. So our three basic types of transformations today: translation is a slide or a movement, a reflection goes over a line of reflection or a mirror to create a mirror image. Rotation has to rotate about a fixed point called the center of rotation. In the coordinate plane, our rotation point is going to be the origin. All of these transformations, by the way, are congruence transformations. Now, you know congruent means same size, same shape. And that's exactly the case, that all of these transformations, whether we're doing a translation, a reflection, or rotation, we're changing the position of the figure, like where it is, but we're keeping the same size and the same shape. So it's not changing what the picture was or the size of it, just where it is or how it looks. So congruence transformations. Here, can you identify, first of all, like what transformation is happening here? Remember, it's translation, reflection, or rotation. Now here, we notice that line. This thing is being flipped over that line. Remember, when you have a mirror, you're doing a mirror image. It's called a reflection. You're reflecting over that line. And this is called your line of reflection. You notice this one has a point identified right here. Now, anytime there's a point, we must be rotating about that point, and you can tell that this shape is rotating. Rotation in this case. Looks like we'd be going 90 degrees. And finally here, the shape looks exactly the same. It's just that every point moved. And actually, the cool thing about translations, if you would draw a line connecting corresponding vertices, that line should always be parallel and the same distance there. And that is a translation. We're translating where it is, we're just sliding it. Alright. Next thing we're going to look at is these transformations in a coordinate plane or on a graph. This is coordinate notation for a translation. Remember, a translation is just a movement up, down, left, or right. And kind of like we saw in Geometry Sketchpad, we know that you can break it down into left and right movement and up and down movement. So this x comma y, this is your like original point or your original figure, or the original points or vertices on your original figure. And then you're translating it, you're transforming it into x plus a, y plus b. Now, why do we have this plus a plus b? Because, first of all, x moves left and right, and by adding a number or subtracting a number, we can move left or right. And y, we know, goes up and down, so by adding a number or subtracting a number, we can move the original points up or down. Now, keep in mind, if I was actually adding a number here, x plus 3, x plus 5, if you're adding to x, you know x goes left and right. If you're adding to x, you're moving to the right. But if you saw actually minus a, like it was x minus 2, x minus 7, you'd actually be making x less, and you know that making x smaller moves to the left. And then with y, if you really are adding b, if you're doing y plus 1, y plus 5, adding to y would move that thing up because y is getting larger. If you really see subtracting b, y minus 3, y minus 10, y is getting smaller by that number, and y getting smaller moves down. So we use this coordinate notation to describe a translation, to describe a movement, whether it's going up, down, left, or right, or a combination of those things. So let's use coordinate notation to describe these translations. If I have an original figure and I want to move every point 3 units left and 8 units up, I'm going to write it this way. So I start out and I just do original x comma y. How am I translating it? Every x comma y becomes what? What am I doing to x? What am I doing to y? Now I know x goes left and right. Here I want to go 3 to the left. Now moving left means x is getting smaller. So moving left 3, we should be doing x minus 3, because x is getting less, and that means going left. If I want to move 8 units up, what's happening to y? Because I know y goes up and down. And if I want y to go up, y is getting larger by 8. So that would be y plus 8. Alright, let's try one more here. If I want to do a translation and I want to move 5 units right, 2 units down, that would mean that every original x comma y is undergoing a translation where x is moving how and y is moving how. If I'm going 5 to the right affects x. Moving right makes x larger, and we're going right 5, so you'd be adding 5, and now x would be going 5 to the right. I know y goes up and down, and if you want to go 2 units down, y is getting smaller by going down, so I would subtract the 2 units to go down. Alright, so looking at up, down, left, right movement affecting x and y. And this would be your coordinate notation. You take your original xy and describe how you're changing it, and we're going to see this on an actual figure here. So my original image, my pre-image, wxyz, has these vertices. I want to sketch the original and its image. Remember, image is the new figure after this translation. So the original xy, x comma y, for each of these points is going to become, or translate to, x minus 5, y plus 3. I guess the first thing is I'll put the original shape on here. W is at -1, 2. X is at 2, 3. Y is at 5, 0. Z is at 1, -1. Alright, so I'm just going to make this quadrilateral here. Cool. Alright, now I'm undergoing this translation. What's going to happen to every x if you subtract 5? Well, x goes left and right. And subtracting 5 from x should move every one of these points left 5. Y goes up and down, but we're adding 3 to y, and adding 3 to y is getting 3 bigger, so we're going up 3. So every single point, I want to go left 5, up 3. So I could start here and just do that. Go left 5 and go up 3. Now this is my new W, or my image W, and something I haven't mentioned to you, but you actually can use this little symbol. It's called prime. So this is W prime. This is my image, or my new W. Notice if I wanted to, I could have taken the original point. It was -1, 2. And I could perform this translation. If I take the x minus 5, the x was -1. -1 minus 5 is -6. Could have taken the y, which was 2, and do 2 plus 3, and that gives me 5. Now let's make sure I put that at -6, 5. Yes, I did. Alright, what about x? X was at 2, 3. Let's do this first here. If 2 is my x, and I'm supposed to do 2 minus 5, I get -3. If 3 is my y, I'm supposed to add 3. 3 plus 3 is 6. So my new x should be at -3, 6. -3, up 6. My new x, so x prime. Let's check, did I go left 5, up 3? 1, 2, 3, 4, 5 to the left, up 3. There we go. And again, I could start at y and just move left up 3. 1, 2, 3, 4, 5, up 3. There's my new y, y prime. Or and then maybe z, maybe I'll take that point again. 1, -1 was the original z. I perform this translation where I take the x and I subtract 5. So 1 minus 5 is -4. I take the y and I add 3. Y was -1. -1 plus 3 is 2. And I could go to -4, 2, and that should be my new z, z prime. And when I draw this image, the new shape, it should be congruent still. Remember, this is a congruence transformation. It should just be slid to x minus 5 and y plus 3 for every point. So it looks good for translations. Next thing we're looking at is reflections. Now remember, reflection goes over a line, and the most common lines, or really the only lines that you're going to reflect over today in the coordinate plane, are the x and y axis. And I did both of these here. This would be a reflection in the x-axis. You notice we're flipping over that x-axis, so the x-axis is your line of reflection. Here we're reflecting over the y-axis. So we have this flipping over to the left in this case. I have x comma y as the original figure. My image would be the one not labeled. And what I want to do is look at what happens to the x and y values when you do these reflections. What happens to every point? Originally it's x comma y, whatever these might be. But now I'm going to this new shape. Well, if you notice, like if I look at these 2 points, which would correspond, right? I'm still going right. Here I'm going up to this point. Still going right. Here I'm going down. What about these 2 points that correspond? Here I go right, whatever it is, and up. But now I'm still going that right same distance, but I'm going down. Wait, if I'm still going right the same amount, or left the same amount maybe. Right and left is x. X is still the same. You're still going right, but first you're going up, then you're going down. First you're going up, then you're going down. So what's happening to the y coordinate? These were the original y's was going up, and now I'm going down, so the y is the opposite coordinate. It's the opposite y coordinate. We're looking at changing whether I'm going up or down because you're reflecting over the x-axis. So you're still going right, whatever the original number was, or left the original number, but you change whether you're going up or down. So what about here when you're reflecting in the y-axis? When you reflect over the y-axis, now these points would correspond, or these points would correspond. So I take my original points, I was going right and up whatever, but now to get to that point I'm going left and up whatever that was. If I look at these 2 points that correspond, I was going right something and up this amount. Now I'm going left, whatever that amount was, up the same amount. So if I think about it, if I'm still going up the same amount to get to corresponding points, the y is the same. But instead of going right, I'm going left. Instead of going right, I'm going left. So x is changing. It's the opposite x coordinate. So it would be negative x comma y when you reflect over the y-axis. So looking at reflections is really just one coordinate is changing its sign. So let's try this in the coordinate plane. Draw and reflect the pattern over the x-axis. So I'm going to reflect over the x-axis here. Let's put these points, the original, in there. So r was at 4, 3. 4, comma 3. S was at negative 2, comma 1. T was at 1, comma negative 2. And I'll draw this triangle. Now think about this, if I'm reflecting over this x-axis, I'm going to the other side of the x-axis. Instead of going up, I'm going down, or instead of going down, I'm going up. So this point S, we're still going left 2, but instead of going up 1, I'm going to go down 1. There's my new S. For this point T, I'm still going right 1, but instead of going down 2, I'm going to go up 2. There's T prime. For this R, I'm still going right 4, but instead of going up 3, I'm going to go down 3. I'm reflecting it over the x-axis. There's R prime. And I'll draw the new triangle, and it should be reflection of the original over that x-axis. And then let's try one where I'm reflecting the pattern over the y-axis here. If I'm reflecting over the y-axis, that's this one. So I'm changing sides of the y-axis. I'm changing my left, right, or my x values. My original L, let's see, we're at 4, negative 3. M was at 3, comma 0. N was at negative 2, comma 1. Draw that triangle. Now this one I'm reflecting over the y-axis, so I'm still going up or down the same amount, but changing whether I go left or right. Here I went left 2. I'm going to go right 2 for that new N, N prime. M was right 3, now I'm going to go left 3 for M. I'm reflecting over the y-axis. L was right 4, go left 4. And draw my image, my new figure. And I have reflected over the y-axis. You're going to have some cool reflections in the homework today. And the last thing we're going to talk about is rotations in the coordinate plane. The center of rotation for all rotations you're going to do today is going to be the origin. Right? That's our favorite point. On the coordinate plane, it's the easiest point to do a reflection or rotation around, and the only thing you have to be careful is you have to identify whether you're going clockwise or counterclockwise. Remember, clockwise, same directions your numbers go on the clock. Counterclockwise would be the other way. And a lot of times your angle of rotation is going to be 90 degrees or 180 degrees. The best way to determine that is to look at corresponding points and draw back to your center of rotation. So if I want to describe the rotation, this is my pre-image, or my original, this is my image. Pick 2 points that correspond, like these two are corresponding points. If I draw from here to the origin, which was my center of rotation, and then I draw from that origin to the new point, the image point, look at the angle that these red lines form, and I would definitely say it looks like a right angle or a 90 degree. You can do the same with other corresponding points. These 2 points correspond. Again, do a line from the origin, from the center of rotation, to each of those points, and again, it looks like a right angle. So the rotation is 90 degrees. If this is my original, this is my image, going in this direction would be clockwise. And that's all it takes to describe that rotation. Keep in mind 180 degrees, that means if you connect the points that correspond, you're going to get straight lines. So that's easy to see as well. Notice also this would have to be 90 degrees because I'm changing one quadrant, whereas 180 degrees you would be changing 2 quadrants or going across. So today, talking about different transformations that change a figure, translations, reflections, and rotations.